take it some simplifying radical examples. This first example, you'll notice that the two expressions are conjugates of each other because one of them is a positive radical and one of them is a negative radical with the same values besides. What happens when we distribute this in, and remember we're going to have to FOIL it, is we're going to end up with the radical term in the middle getting canceled out. So here's what we're going to have. 8 squared, 8 times 8, plus actually negative 8, let me redo that, negative 24 root 11, that's this one, the first and the last, and then your inside terms are going to be a positive 24 root 11, and that's why those cancel out. And then the last terms are going to be minus 9 times the square root of 11 squared, which is just 11. Now when I simplify this, I get 64 minus 99, and when I simplify that, I just get 35. So your answer is 35. Let's take a look at another one. This is different. Notice it's a cube root. When we have a cube root, what we're looking for is 3 factors to be able to break that jail there. Just like with a square root, we look for 2. With a cube root, we look for 3. So here's what I like to do. I like to just use the factor trees to look at what 108 is. And that's going to be 2 and 54. 54 is 9 times 6. 9 is 3 times 3. 6 is 3 times 2. And you can see when you do that, I'll change to red, that you're going to have 3 3's there, which means this thing is going to simplify into 3 times the cube root of, and the things that stay behind are 2 2's, which is 4. So that's 3 cube roots of 4. Now let's do the same thing with 32. 32, let's break that down. That's going to be, of course, well, you probably know what it is. It's going to be 2 times 16, and 16 is 8 times 2, and 8 is 2 times 4, and 4 is 2 times 2. So really 32 is just 5 2's, and of those 5 2's I can take 3 of them, which is actually just 8, and the cube root of 8 is 2. So a 2 breaks jail. So this is going to be 10. Now I've got that 10 on the outside, so I have to multiply that 10 by the 2 that's going to come out, so that's going to be 20. And it's going to be the cube root of what stays in, 2 times 2, which is 4. 4 stays in, which is convenient. In fact, let me write these over here. This is 3 cube roots of 4 plus 20 cube roots of 4. And now let's do the same thing with 500. I'll change colors. 500 is going to be 100 times 5. 100 is 10 times 10. And so what I'm going to have is 3 5's, which means a 5 is going to break jail. There's 3 of them, and it's the cube root that I'm looking for. And then there's 2 2's left over, which is, again, the third root of 4, which is very convenient because now what I can do is add these 3 terms together because they're all cube roots of 4. I've got 3 cube roots of 4 plus 20 cube roots of 4 plus 5 cube roots of 4, which equals, when I add those together, 28 cube roots of 4. And that's your answer. One more example. Little different problem. So I've got a couple things I have to do. First of all, I have to rationalize the denominator. So I'm going to multiply this by the root 5 over root 5. When I do that, I'm going to get, let's just go ahead and write this. 4 root 5 comes down. Now I've got plus 35 over 5 root 5. That's going to simplify in just a second. And let's do 125. 125 is 25 times 5, and 25 is a perfect square. It's 5 times 5, so is going to come out. So this is going to be negative 5 root 5. Again, this simplifies down into 7 root 5. So now I can add like terms together. 4 root 5 plus 7 root 5 is 11 root 5. Minus 5 root 5 is 6 root 5. That's your answer. That's how you do those problems. Radicals.